Hello students, today we will be dealing with the next topic, that is topic number 9, multiplexers. In the previous topic we have seen regarding encoders, we have seen regarding decoders in the previous classes. So the next topic is about the multiplexers. We'll see what about this. Basically a multiplexer is also called as data selector. As you can see in the block diagram, a multiplexer consists of some of the data inputs. It consists of a control signals or control inputs and one output. Basically, multiplexer is a circuit which consists of many inputs and compulsory one output. There will be only one output. It is many to one. Again, in this inputs, we have two inputs. One is data inputs and another one is a control inputs or select inputs. Control inputs are also called as select inputs. What is the meaning of this? So we came to know there will be only one output. Coming to the input, there are two types. One is data input, second is a select input. For example, consider now two variables A and B. For two variables A and B, we will be having four combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1. I am going to repeat again. Consider now two variables A and B. For two variables A and B, I will be getting four combinations, 0, 0, 0, 1, 1, 0 and 1, 1. So these two variables A and B are called as N control signals or select inputs. So if I have two control signals or two control select inputs, there will be how many combinations? Four combinations. These four combinations are nothing but data inputs. So they have given as 2 to the power of n data inputs and n control signals. Control signals are also called as select inputs. So remember, multiplexer is a circuit which consists of many inputs and one output. Again, in inputs we have two types. One is data input, select inputs. For example, if you have three variables A, B, C. For three variables A, B, C, how many combinations will be getting? We'll be getting 8 combinations. So these three A, B, C are select inputs. 8 combinations are nothing but data inputs. A multiplexer is also called as data selector since it selects one of many inputs and steers the binary information to the output line. That is, it selects one of the inputs and it gives us the output. So coming to the types of multiplexer, we have 4 types. 2:1 multiplexer, 4:1 multiplexer, 8:1 multiplexer, 16:1 multiplexer. We will be studying first three types of multiplexers in this video. So as you can see, always output is 1, 1, 1, 1. Means what? Multiplexer, you can have any number of inputs but only one output. First, 2:1 line multiplexer or 2:1 MUX. It is also called as MUX. So as you can see here, 2:1 multiplexer means here we have two inputs, two data inputs. Remember, two data inputs and one output. If I have two data inputs, how many select inputs will be having? One select inputs. Two data inputs means one select inputs. So as you can read here, the circuit has two data inputs, one output and one selection line. Selection line is select inputs or control signals. So yes, it is represented with S. So as you can see here, logic diagram, we have S at the bottom, two inputs for a AND gate. One is input 0 and input 1. Select input S. This, and we have a NOT gate here. So for first AND gate, 0 will be supplied from NOT gate. That is, S will be 0 for first AND gate. For next AND gate, S will be 1. How we will get this? Look at the truth table. First, S and Y. That is select inputs and Y is output. If S is 0, I will be getting Y. If S is 1, I will be getting input 1 as a result. If S is 0, I will be getting I0. If S is 1, I will be getting the input as I1. So these two AND gates are combined together to get a OR gate. Why OR gate is connected here? To get a single output, because as we know the objective of multiplexer is to get a single output. So we have a OR gate, we have single OR gate to get one output. So the working of this is, go to the second point, when S is equal to 0, remember the upper AND gate is enabled. Means what? The upper AND gate is activated. What is S here? Select inputs. When select input is 0 means what? The input is from NOT gate, as you can see. So when S is equal to 0, the upper AND gate is enabled or activated, and I0 path is the output. So what will be the output? I0, as you can see in the truth table. When S is 0, Y is equal to I0. Next working, when S is equal to 1, that is when S is equal to 1, the lower AND gate is enabled, and it is not 1 1, it is I1. It is input 1 is being activated. It is activated. Next, both AND gates are connected. These two AND gates are connected to a single OR gate to get what? One single output, because our aim is to get only single output. So the 2:1 line multiplexer, remember, as we know, it has two. Basically multiplexer, it has many inputs and one output. Again in inputs we have two types. One is select input, second is the data inputs. Here in this case, 2:1 line multiplexer, we have two of the data inputs, one select input, one output. Coming to the working, when S is 0, upper AND gate is activated. When S is 1, lower AND gate is activated. Finally, these two are connected to OR gate to get what? To get a single output. Similarly to the 2 line, here we have a 4 line multiplexer. Means what here? We have 4 data inputs. If I have 4 combinations of data inputs, how many select inputs will be having? 2 select inputs. So 4 of the data inputs, 2 select inputs and 1 output, which is compulsory. As you can see in the logic diagram, we have 4 inputs, I0, I1, I2 and I3. How many select inputs will be having? 2 select inputs. One is S1 with a NOT gate and S0 again with a NOT gate. So if I have 2 of a select inputs, S1 and S0, imagine S0 and S1, how many combinations will be getting? 0, 0, 0, 1, 1, 0 and 1, 1. So if 0, 0, as you can see for the first AND gate, I0 is connected. Next 0, 0 means what? 0, S0 is also 0, S1 is also 0, which is connected. Similarly, 0, 1 is connected for the second AND gate. Next 1, 0 is connected for the third AND gate. 1, 1 is connected for the fourth AND gate. Select, we need to connect both the inputs for the AND gate. Data inputs also and select input also. We need to connect both data inputs as well as select input. Combinations are 0, 0, 0, 1, 1, 0 and 1, 1. Combinations are 0, 0, 0, 1, 1, 0 and 1, 1. So next Y. These are nothing but what? Output. If 0, 0 is connected, I0 will be activated, that is first AND gate is activated. If 0, 1 is connected, the second AND gate is activated, that is I1 AND gate is, second AND gate is activated. If 1, 0 is connected, the third AND gate is activated, so I2 will be the input. And if last one, if 1, 1 is connected, last AND gate is activated, that is I3. Finally, all these AND gates are connected to a single OR gate to get one output. So going to the working of 4:1 multiplexer, when S is equal to 0, 0, the first AND gate is enabled or activated and I0 has a path to the output. It is not 1, 0, it is I0, input to 0. Next, when S is equal to 0, 1, the second AND gate is enabled and 1, 1, and I1 has a path to output. Next, when S is equal to 1, 0, the third AND gate is enabled and input 2 has a path to the output. Next, when S is equal to 1, 1, the lower and last AND gate is enabled and I3 has a path to the output. So finally, all the 4 AND gates are connected to a single OR gate to get one output. Finally, similar to 4:1 multiplexer, this is a 8:1 multiplexer. How many data inputs will be having? 8 data inputs. If we have 8 data inputs, we'll be having how many select inputs? 3 select inputs, S0, S1 and S2. So similarly to that, we have S0, S1 and S2. We have 8 AND gates. We have combinations like for first AND gate, 0, 0, 0 is connected along with the input. First input, what will be having? We'll be having 3 of inputs, that is S0 is also 0, S1 is also 0, S2 is also 0. Similarly, we'll be having up till the last AND gate, and we'll be getting the output like Y0, Y1, Y2 up till Y7. All these are connected to a one OR gate to get one single output. All these outputs are combined to get one single output. The connections here are, if you notice the first AND gate, one is input is connected, no doubt. Next is S0 is 0, that is I have taken connection from 0. S1 is also 0, S2 is also 0. All are 0, 0, 0. Coming to the second AND gate is what? 0, 0, 1. Coming to the third AND gate, 0, 1, 0. Coming to fourth AND gate, 0, 1, 1. Coming to next AND gate, 1, 0, 0. Next 1, 0, 1. 1, 1, 0, 1, 1, 1. It is nothing but 3 variable truth table. So this is the logic diagram of 8:1 multiplexer. So as you can see the truth table, first is S0, S1, S2. If all are 0, output will be D0. That is input is D0 is nothing but input here. Next 0, 0, 1, D1. Next 0, 1, 0, D2. 0, 1, 1, D3. 1, 0, 0, D4. 1, 0, 1, D5. 1, 1, 0, D6. 1, 1, 1, D7. So this is the truth table of 8:1 multiplexer. So coming to the working here, when S is equal to 0, 0, 0, then the first AND gate is enabled and I0 has a part 2 output. Similarly, when S is equal to 0, 0, 1, the second AND gate is enabled. When S is equal to 0, 1, 0, the third AND gate is enabled. Similarly, when S is equal to 0, 1, 1, the fourth AND gate is activated. When S is equal to 1, 0, 0, the fifth AND gate is enabled. When S is equal to 1, 0, 1, the next AND gate is activated. Next, when S is equals to 1, 1, 0, next AND gate is activated. So finally, all the 8 AND gates are enabled, and all the 8 AND gates are connected to a single OR gate to get one output. The next is nothing but design of a 4:1 multiplexer using a 2:1 multiplexer. So we have studied 3 types of multiplexers. One is 2:1 multiplexers, next is a 4:1, and next is a 8:1 multiplexer. Coming to next, design of a 4:1 multiplexer using 2:1 multiplexer. So if they give us a question like this, consider the 2:1 multiplexer, 2:1 multiplexer. So the input for 2:1 multiplexer is what? 2 inputs, 1 output. Similarly, 2 inputs, 1 output and 1 select input. So these two outputs are connected to another multiplexer to get one output. Next, design of a 8:1 multiplexer using 4:1 multiplexer and 2:1 multiplexer. Consider now 2 4:1 multiplexers. For each 4:1 multiplexers, how many inputs will have? Definitely 4 inputs. That is I1, I2, I3, I4, I5, I6, I7, I8. Then how many select inputs will be having? S1 and S0, which is connected to both the multiplexers. These two output is connected to a single 2:1 multiplexers. So this for 2:1 multiplexers, we have got the output from 4:1 multiplexer and select input. So we'll be getting one single output. Next, design of a 16:1 multiplexer using 2 8:1 multiplexer. We have 2 8:1 multiplexers you take down. Next, for these 8:1 multiplexers, I have 8 inputs, 3 select inputs as you can see. Finally, the output of these two is connected to 2:1 multiplexer along with one selector input S3. They may ask a question like this also. Design a 16:1 multiplexer using 4 4:1 multiplexer. So consider 16. How it is divided by 4? 4. 16 divided by 4 is 4. So consider 4 4:1 multiplexer. I0 to I15. It is not 10. It is I0, I1, I2, I3, I4, I5, I6, I7, I8, I9, I10, I11, I12, I13, I14, I15. I is input. For these multiplexers, we have to select inputs. Finally, I'll be getting a 4 outputs. 4 outputs is connected to a single multiplexer. Again 4:1 multiplexer only with 2 select inputs S3 and S2 to get one single output. So this is the end of a multiplexer. So totally we'll be studying 3 types. One is 2:1 multiplexer, 4:1 multiplexer, next is 8:1 multiplexer, and they may ask about designing of a multiplexers. Thank you.